to build a structure, not just a structure, but a sequential structure to hold data / information. What have I told you here? I said that your linked list is an ADT, an abstract data type, which uses dynamic memory allocation in order to build a sequential structure to hold data or information. This is kind of high level because we don't know what an abstract data type is in concept. So maybe before we talk about linked lists, we can just consider what is an abstract data type. And an abstract data type is a structure in computing that holds information, but there are rules about how information could be added to the structure, and there are rules about how information could be retrieved from the structure. Okay, so an ADT is a structure that holds information and has functions / rules about how info can be added or removed from the structure. Okay, so it's not like an array, in that if we have an array is essentially a data structure, and an array allows us to just add information to that structure, any location. We don't have to call any special functions to add information from an array or to remove information from an array. We don't have any rules regarding, rigid rules regarding how data is supposed to be added to an array or removed from an array. Are you all with me? You all understand?
So you could kind of prove it, please.
Right. Okay. And I will go over it as an example. We haven't met this yet, Varun, so I don't have any notes inside of there about it. Okay. So an abstract data type, as I said, is not only a structure, but there are rules about how information can be accessed or removed from the structure. And one example of an abstract data type is a linked list. Okay, it's defined by its behavior. And so what we talked about in terms of a linked list being last week, in terms of a linked list, we identified that a linked list is made up of nodes. And a node is made up, right? So it's made up of a node, and a node has two parts. A node has two parts. A node has the data element, and a node has the pointer to the next node. So this is what linked lists are made up of. We don't have elements like in an array, we have nodes. And we have to add or remove nodes from a linked list in terms of the how data is added or removed from this structure, right? So we say data is added / removed from a linked list via the following operations. And we have the insert operation. Insert operation adds a new node to the linked list. And the delete operation removes a node from the linked list. We also establish that the linked list, must have a pointer for the first node in the linked list. So a linked list must have a pointer to the head node, to the head or the first node. Okay? So what does that mean? That means if it is that we have a linked list and we know that we create a linked list is a collection of nodes. So if I have this node here and this is my first node, the head pointer points to the first node. If there is only one node in the linked list, then this first node points to null. If there are more nodes in the linked list, then each node points to another node location, right? Remember, every node is a location in memory. And the last node, right? The last node always points to null. Anybody here remember what null is? We've used null before. We've seen null before, yes?
Null is nothing.
Essentially, null is the absence of a memory location address. Okay? Null is the absence of a memory location address. So our linked list is made up of nodes. Our linked list is made up of nodes that point to other nodes. And when there are no more nodes to point to, the last node points to null. We have a marker called head, which always points to the first node. So we have a scenario where we have to be able to create this linked list in C programming. Okay, and this is a data structure that allows us to essentially manipulate memory. The purpose of a linked list is that the linked list essentially is the starting point for understanding other structures that you will meet later on, like binary trees and you know, I can't remember if hash tables might utilize dynamic memory allocations as well. But this is essentially a building block for future structures that you will use. Okay, so it mightn't seem very useful now, but if it is that you have to manage memory in a way that you know, you want to speed up data access, then these structures are going to help us when we learn how to manipulate various structures. We can also utilize we could also utilize the first and the, sorry, we could also utilize what we will learn, which is stacks and queues, and implement them using linked lists. Okay, but for now, let's just focus on the concept and the implementation of a linked list. Everybody with me so far? Does anybody feel like, well, boy, I don't know what he's talking about? Anybody feel like they're there? All right, good. Yeah. No. Chelsea, what did you say? You said no, Chelsea?
Yeah, I said no.
All right, good, good, good. Okay. All right. So we want to try, our objective today is to see if we could just simply implement a linked list. Okay. We're going to, I'm just going to ask for 2 minutes to get some water. We're going to then take a look at how we create a linked list, the process. We'll take a look at it in like a pseudocode or a narrative. We're going to think through it together, walk through it. What is the purpose? How we will do insert, how we will do delete, and then maybe we can implement it in C. And also we can have probably a little discussion on ways that we could modify this. All right. So I'm going to just leave this here up for the 2 minutes that I just go and get some water. And then we'll get into making a linked list. Yeah. Just to address what was said in the chat. Okay, with what Varun said with zero and what Joshua said, right? Joshua is correct. If you think about memory as of course being addressed, the address space must start somewhere. So zero is correct. You could have memory at location 0. Think about memory as like how we would have an array. It could have from 0 up to whatever value represents the limit of the array for us to store values into. If it is that, however, we had a location like -1, an array location like -1, that's an array location that cannot exist. So, Joshua is, sorry, not Joshua, Varun. If we have to think about null as a concept, we could think about null being like -1 as an array index. It's a value that does not exist and cannot be accessed. That clear it up for you? Yes, no. All right, good. So The weirdest thing just happened. I turned on my Bluetooth headphones and my Bluetooth mouse just disconnected itself. It just decided, well, yeah, I'm not playing anymore with this. So it started back working. Could somebody just say something? Let me make sure the headphones working now too.
Your mouse find that you're cheating on
Yes.
it with your headphones.
Yeah. The mouse decided to, what it realized that me and the headphones are just friends and we good to go. Everybody is getting along in harmony. All right. So we're going. We keeping it simple with the concepts that we're talking about with the linked list. So if it is that we are looking to map out the development of a linked list, okay, we know that we have to have some structure called a node, and we have to be able to represent this structure in code. So we have our node and we have our code. Hey, this is one time for the year that I get to do that. Nobody's there. You could at least hit the little laugh emoji thing to give me a little nothing. Node code, it was cool. I did a voice. Ah. Wow, everybody's like, just get on with it. So all right, so we have the node, and we have a code associated with the node. And to be able to create a node, we have to have some kind of structure. And remember, I'm keeping it as pseudocode right now. So our node has two parts. The part that holds the data, and we can hold one or more different data elements inside there. And we also have the pointer, right, which points to the next location of the node. So if it is that we had to create this, we could have created via a structure node. I like Joshua. Joshua keeps it real. You see, my joke was not hilarious. I take that note and I'll be better in the future. All right. What kind of data we want to store inside of our node? Let's say, for instance, we just want to store something simple, just a name. So we have a string for a name, right? And then we have this part here that is of data type what? What does it point to? It points to another node. So it pointer node next. So essentially, this part here will hold a name, and this part here will hold the next node. And I could end my structure here. And so this code that I have on this side here represents the node that I have on my left hand here. And now if I want to create values to link together, I can create nodes and link them by pointing them to previous nodes. But I also have to have something of type node, right? So I have to have a pointer of type node that is the head of the node. And what does this do? This pointer of type node that is the head of the node is essentially something that says, hey, when you create your first node, I'm going to set the head node as this node. I also have a pointer of type node that will show me what node I'm currently on. Okay? And so current will show me essentially what is my current node. Why do I keep information on the head node, and why does that information have to stay relatively static? It is because if I lose the location of my head node, I'm not going to be able to traverse my linked list. Okay. So the next thing that I do, once I declare these things here, is that I'm going to say head is equal, and I will call a function that said, or let me do it a little differently here. I'm going to call a function that says create new node, and I'm going to say head. What do I have here? I just said create a new node and assign it to wherever head will point to. Okay? And so that's what happened there. I just created a new node and allowed head to point to this new node. But we want to put data inside of this new node. So how do we put data inside the new node? We say print, enter a name, right? We say enter name, and we say input, right? Sorry, I made a mistake. Before we say enter the name, because this head node is also our current node, I can say that the current node is equal to the head node. So what did I do there? I also said that, well, this is my head node, but this also happens to be the current node, because this is the only node that we have. And then I say print enter name, and I would say input current dash name. So whatever name the user decides to put inside there when prompted is going to be stored inside of this current node, which in this case is also the head node. Everybody's with me? Are you with me in terms of how the algorithm is going? Yes, thank you, that one person who responded. All right. So we say enter a name and input car dash name, and then we put the name inside there. Okay, so we could put a name inside here. We could put Jude. And then what do we have at this point? At this point, if it is that we wanted to make a linked list of only one node, we would have said that car dash next is equal to null. And what would this have done? This would have taken this value here and put null there. You understand what I just did? I just closed off. My list is one node long. That's all I have, one node. Right? So we have this linked list, and this linked list is created. This linked list is something conceptual, right? We're taking the memory of the computer and we're putting the addresses in pointers, and we're linking those pointers to each other. So what if I were to continue this now and I wanted to create a new node? I wanted to create a new node to link to this previous node. What would I have to do? I would then say, if I want to create this new node, I could say create underscore new node at car dash next. What am I saying here? I'm saying that this new node is now going to be what is now going to car dash next will now be pointing at the memory space that this new node was created in. Okay, that's what this line does. This line says, okay, previously it was null, but now I've just created a new node. Let car next point to that new node. That's what I did here. I want to add some data to this node. So but before that, let's make this the current node. So we could say current is equal to current dash next. So what do we do here is that now this current pointer points to this node, because that's the truth. Current, this is the most current node. It's the most recent node. So now the current pointer is pointing to this node. If it is that I want to add a value to it, I could say input car dash name. Ask the user to put a name inside there. Let's put the name Alicia, Alisha. So Alicia is now located in the data element of the most current node. If it is that we want to close off this and make this to be the last node of the list, then we will say current dash next is equal to null. And what does that mean? We have closed off this here. So we've created a linked list, and we created it node by node. And essentially what we did here, identifying that we're reserving space in memory, and then taking that reserved space and allowing a pointer to show us where that reserved space is, so that we can store data directly in memory and not really like through a variable or something. So this is what we did just now. Any questions so far? Let me get some questions now. Somebody ask me something. Let me ask you something. Is the concept bad? Is it not bad? How is it for you?
So it's not bad, but actually I have a question, right? For the head node, right?
Yes.
You could put it to like literally just be a name, or it have to do something. So you see, how does you have that one input in a name? Is it that you for whenever you're making a linked list, that's how the first node would have to be doing something?
Well, the node is a container, you know. So it's whatever you create your struct to hold. So if it is that my struct is created to hold numbers or values or some sort of statistical data, information on a specific date. Is that what you're talking about? The data inside of here?
Yes.
Or is it that you're talking about the actual? No, well, yeah, it's whatever I have inside of here. So whatever I want to keep inside of here, I will store that inside of the data element part. Remember, because this is a struct. And if we remember structs, we know that we have elements inside of structs, right? Structs have members. So name is the member inside of this. So I didn't have to call it name. I could have called it number and put it as an integer. I could have called it price and put it as a float. With me?
Yes, sir.
All right. Okay. So we want to move over to C, and we want to start to try to implement this. Okay, we're going to have some fun, because we know that programming is always fun, right? I don't know, is it just me or you guys just don't say yeah to questions that, you know, I expect you guys to say yeah to. All right, even the chat quiet.
I
All right.
just prefer if I can 100% agree with it, the heart, better just not say anything.
It's better you don't say anything.
Yeah.
I mean, I would appreciate, you know, like even a grunt, affirmative grunt, like, you know, yeah.
I say you
Okay.
could get that. Yeah, you could get that.
I see Alicia. I just feel the effort that you put into the typing ye fun. All right. Okay, I'm going to share the compiler window now, and we're going to take a look at the code to make this happen. Okay, we're not going to do it exactly like how we had it in the example there just now. We will have a couple other things that we want to change, but we will we will create our linked list from scratch. Oh yes. Just give me a second now. No. Right. So we start off typing, root stdi. Oh. Right. So the first thing that we want to do, and we've agreed among ourselves, we have agreed among ourselves that we want to wow, David. Yeah, we agreed. We've agreed to store a series of names in the linked list. Okay, so we have our struct. We have type define struct. I'm going to just I type define in the struct so that I can name it node, right? So I put type define struct n. We have our char name. Our name could be about 20 characters, and our struct node next, and this is a pointer. And what the pointer is that this is going to be the pointer to the next node in the linked list. This here is the data that this node will store. The name of this node is node. Of course, as I just identified, we can declare a variable of type node called head and current. So what is this? This is the variables to hold the memory address of the head node and the current node. So the variables to hold the memory address of the head node and the current node. And then we can say int main, and we start off. Okay? We go bravely. Go forth, and we will want to store our first set of information inside of a node. What do we have to do to store information inside of this node? According to what we did in our example just now, we said that the first thing we want to do is we want to create a new node, and then we want to store some information on somebody's name inside of there. I'm just going to create a single node. Okay? I'm going to create a single node. So we have here, how do we create a node? To create a node in a linked list, to create a node in a linked list, we can, not can, but will allocate this space in memory and assign it to the head pointer. So we have to allocate the space in memory and assign it to the head pointer. So we say head is equal to, and this looks more difficult than it is, eh? We put struct node pointer, alloc size of node. What did I do here? Now this is it's very, very, very simple. Okay, and maybe I should annotate the screen to just discuss it. So let me share the whole screen. All right. What we have here is, this is the essentially, prior to this, the head pointer pointed at nothing. Okay, we didn't give the head pointer any sort of memory address, value, or anything so to point at. So what we did say, however, is, does this look familiar? Anybody could tell me what this reminds them of or what it is? When we put a data type in brackets in front of an operation, that's called a what? I didn't hear what you said.
A typecast?
A typecast. So we're saying that we're going to typecast whatever is returned from this side so that it could be stored in the format that a struct node pointer could understand it. Okay? We have this section here. So this is a typecast. We have this function here, size of node. What does this tell us? This size of function here gets the size of this here, whatever the byte size of it is. However, how many bytes do we need to store a character and a node pointer? So we get the size of the nodes, of the node struct in bytes. Okay? We work out how many bytes we need to store this struct, this node pointer. And then we have malloc. Malloc then takes whatever size is returned here and reserves memory specific to that size. Reserves memory specific to this size. So if it is that size of, let's say for instance, the size of this node was 87 bytes. All we're doing here is that we say out of the free memory of this computer system, reserve 87 bytes and store the address of those 87 bytes in this typecasted format. In this typecasted format, so that the head variable is going to save those 87 bytes in a way that this head pointer could reference. So essentially, whatever 87 bytes that we have, let's say that this is the whole memory of the computer, and this is the 87 bytes that we want, allow head to really and truly store that memory address. And that's all that we did. That's all that we did. That's what this one statement is doing. Anybody does not understand what I said there? Anybody didn't understand what I said there? Oops. Oh. I don't know why this, for some reason, my stuff is not allowing me to see it this way. I'm gonna use a different snipping tool to save it. You're seeing the compiler though, right? Okay, I'll go it over one more time. Just allow me to put this page into the notes. Okay? So I'm going to put this page into the notes because I feel like you all would need it, at least to understand. All right, good. So what I'm saying is that this statement here is a loaded statement. It's a loaded statement. We have a lot going on inside of this statement. But it's like any other programming statement. It's just it's just your basic it's your basic what you call it, assignment statement. We say size of node will get the size of the struct in bytes. So basically, I'm going to say calculate the size of node in bytes. And everything is calculated in bytes. Everything. You have an integer. An integer could be a 32-bit a 32-bit number, right? So 32 bits would be 4 bytes. Okay. If it is that you have a long integer, which might be a 64-bit value, then that's 8 bytes. All right, so it tells the computer how many bytes of memory to calculate a particular variable in. And then the malloc instruction says just put aside memory. Put aside memory. So put aside memory of how much of a node bytes is. And ensure that the memory address of that memory put aside is structured in a manner that struct node could understand, because we're storing it in a variable of type struct node pointer. So if it is that we say we in the memory of the computer, we put aside 87 bytes, then get the address for that in a way that a node pointer could understand. Why? Because when we call head, we have to be able to say, okay, well, whatever head is pointing to, we could understand it and find that block of memory to read. Are you with me? Are you with me? Right, good. So, you know, as I said, I know I told you all, you can't say I don't tell you all that, but I told you all that linked list concept is probably the hardest concept that we'll do this year, right? Once we could get an understanding list, you shouldn't have a problem understanding anything else in computer science, because linked list is probably the hardest thing that we have to do this year. So we now have to create a node in a linked list, and we allocating the space to head. So once we have a way to access that piece of memory, we could now manipulate that piece of memory. Okay? But remember, while we are using a struct, and normally the way that we would manipulate elements in a struct is by using the dot. Okay, so if it is that we had created a regular variable of type node, we would have said head dot name. In this instance, because head is a pointer, we change the way that we reference it, right? We'll be using head dash greater than sign to form an arrow name. So that's the way that we'll have to reference it. That's just how C is. That's the syntax of the language. Okay? So we want to store a value inside head, and we also want to let current be where head is. So we can say cur is equal to head. So make cur the let's say make head the current node, or put the head as it's the only node we have. Head is the current node, and the current node is head right now. And then we could say current cur is dash next is equal to null. Make this node the last node. So we make this node the last node, and then we also want to store a value into the node. So next thing we want to do is store a value into this created node. So how do we do that? We prompt the user. We say printf, and we say please enter a value. Say please enter value. And then we say scanf, what data type is this? This is a string. Where do we want to store the string? We want to store it in current dash name. So if it is that I want to print out the value, right, just to show that we actually store the value, print the value from the node, we will say printf the name stored in the node is current dash name. All right, and we could say get char and return 0. And if we run this, all right, where block size of node, where's my error? Expected node. Oh, sorry. I have the my bad. I have this on the wrong side. Right, and I forgot a semicolon here. So please enter a value or name. And we enter Tom, and the name stored in the node is, and I did not write a %S. Yeah, I just put a colon for some reason. So that's why the name didn't come out. They forgive me, I'm tired. I'm eating this one and had my little time. So what did we do here? We created a node. We created a single node. And then we printed out the value from the node. Yeah, the next thing that we will do is that we're going to build this list. But I just wanted to show you in this example, this first thing that we do here is how we create the node and how we store value into the node. Okay, Hazard. So let's see if we could build a list. But before I build the list, does anybody need clarification on anything that I've done? All right. Okay, let me just see some reactions to make sure they're still here. And I haven't decided that, you know, just okay, I see in Jaden. Okay, Kalika's still here, David. All right. Okay, all right. So I'm seeing some people reacting, which is good. All right. So how do I get this to be a list? Well, for it to be a list, I mean, of course, I'll have to have some loop. I'll have to loop to be able to put values in to create the list. And I'll have to loop to put some values in to print out the list. So this is just the first node, right? I'm going to create another file. And this next file here is going to, right? Linked list. Creation, let's see. Okay. So I have the whole setup from before, the same setup from before. And again, I want to say in the beginning that head is equal to null and car is equal to null. And what does that tell me? That tells me that the list is empty from the jump, right? Head isn't pointing anywhere. We don't have any current pointer, okay? And I will use that in the development of the list. So essentially, I will say do what? We're gonna assume that we're gonna put in a name. Should we assume that we are putting a name? Yeah. Do, okay, while, and we will come up with the while condition for stopping the list in a little bit, right? Probably we'll enter some specific name or something like that, you know, to get a list. But we want to take a list of names. We want to store a list of names in a linked list. So what do we want to do? We want to, first things first, let's see if we could get the name. Printf. So printf, please enter a name. We could say gets, and let's store this name in some temporary char, name underscore temp. Okay, some temporary name. So temporary variable to hold the name. Okay, we ask for the name, so we prompt for the name. Store the name from the user. So we're going to store that inside of name temp. And then we could validate the name, right? So we could say as long as the name isn't, what's a name to enter to stop? Let's say if we enter the word stop. So we can say if what? If name underscore temp, right, comma, the other string compare. So I'll have to include the string.h library. And the rain has come down. So if the quality of the video goes bad, it's the rain. strcmpi. If string compare name temp with the word stop is unequal to 0, what does that mean? If the name is not the same as stop, so if the name is not the word stop, if the name is not the word stop, what do we want to do? We want to put it inside of this linked list. But we have to know whether or not this is the head node, this node is the first node, or if it's not the first node. So we have to be able to say, okay, if the first node, if this linked list is empty, then if this linked list is empty, then we will create that first node. So we can say if head is equal to null, if the first node does not, or let me just say if the list doesn't exist, if the list does not exist, then what do we want to do? We want to create it. Okay, so we want to create the first node, create that first node and assign it, because we don't ever want head to move. Current could move. Current could always be the first node, the second node, the third node, but the first node must be the first node. Or else later on we will not be able to traverse this list. We wouldn't be able to go and print out all the values inside of the list. Okay? Sorry. So we do the same thing that we did here. We say that we create that head is equal to struct node. Right? I'm just gonna copy the line. It's much easier to just copy the line. The head is equal to struct node. Make that node, assign it to head. Okay, so create the first node and assign it to head. Right? And then we say current is equal to head. Set the current node to the head node, because this is the first node. We can say current dash next is equal to null. Right? Set this node as the last node, because it's the first node in this instance and it's the last node. Okay, you'll just close off the nodes, because remember, when we traverse in, we have to know where the last node is as well. Okay, so what if I only enter one name and then I enter stop? Then we'd only have that first node. And then we can say current, not current, but strcpy, string copy, the destination is always first. So string copy, where do we want to put it? We want to put it into car dash name. What do we want to put in there? We want to put name temp inside of there. So copy the name into the linked list node. But what if this is not the first node? if it's not the first node, then it would have meant, okay, so if it was the first node, let's say for instance, head was pointing to null. What we did just now, and current was also pointing to null. What we did just now was that we said, okay, if head is equal to null, we create that node, let head point to it, let current also point to it, let this node also point to null, and then put in the name. That's what we did. But what if we go around another time and get a name, and that name is not stop, and so we have to put in another name? What do we do then? We have to create a node at current dash next. So where this node would point at, then make that current. So we would then, the first thing that we do is we would reserve some space and let current dash next point to it. Then the next thing that we'll do is that we don't move head, but we move current to point to this node. We would let current dash next point to null, and we would let current dash data be another name. Okay? Do you understand the sequence of events that we're going to attempt? This program is almost finished, eh? It's actually almost finished. All right? So let's go forward with this. Let's do this. We said that the first thing that we would do is that we would say car dash next is equal to this whole, right? This whole, no problem, Michaela. So car dash next is equal to this node stuff here. And then we will say that car is equal to car dash next. So we move car onto, so we create the next node space. Then we will make car the next node. Then we would say car dash next is equal to null. So make this new node the last node, and then we would do our string copy for, right? Copy the name into this node here. So we copy the name into the linked list node. Everybody's with me? Everybody's with me? All right, and we do this, of course, while strc, let me just say while else stop is equal to 1. All right. We start off with stop is equal to 0. Stop is equal to 0. So while stop is equal to 0. So we set the value to stop to 0. So set the stop flag to 0. To control taking in names. We said if the name is not the word stop, then we will do all of this regarding nodes. Otherwise, set the stop flag to 1. Loop while the stop flag is 0. So we'll continue looping while the stop flag is 0. As long as the stop flag is 1, we stop. Okay? Let's see how we take in some names. Just afford me Oh, sorry, this is int stop, right? Just afford me a few minutes. Semicolon missing here. Semicolon missing here. Right. That is equal to struct mode. Silent and no pointer structing. Is I getting this error over here? Yes, I was, but it was working. So let's push forward with it, and I'll see later on how I could clear up that error. Let's see if we could enter a name, Jane, Tom, Slim, Stop. But how do I get this to print out? How do I get my data to print out? To print out the data, right? To print out the data, we would say car is equal to head. So set the value of car to head. So we start back at the top of the list, and we can say while what? While cur is unequal to null. While cur is unequal to null, what do we want to do? We want to printf %s \n, and we're printing out cur dash name. We will do this, and then each time we say cur is equal to cur dash next. So we move to the next node after we print out each name. So as long as cur, once cur is not null, print the name in cur. Set cur to the next node. And that will continue until cur gets the value of null, and then we have to stop. So let's see if we'll get some values printed out. Jaden, Ryan, Clee, Ira. Stop. So we have some values printing out from a linked list. We may have some questions. Anybody have any questions? So everybody understand, everybody's fine with what we do here today. This code is no questions. Everybody.
So I'll ask you a question so you don't worry.
All right. So you all want to internalize it, and then ask your questions about it. Yes?
Yes, sir.
All right. Okay. Well, then I hope that we're good. It is 2 minutes past 3 o'clock. So I'm going to stop the recording now.